new feature on YouTube here, as well as podcasting, which is the Neuro-Op Gurus podcast of Journal Club. I'm happy to be here with my friend and colleague, Elizabeth 14. Hi, Elizabeth.
Hi.
From Montreal. And each week we're going to highlight a new article. And today's article was in the JNO, and it's about Phoms. What a weird name, Elizabeth. Tell the audience what a Phoms is.
So Phoms, it's actually self-descriptive. So the name is actually an acronym. So it stands for peripapillary hyperreflective ovoid mass-like structure. So they made it simple with Phoms, basically.
So it's peripapillary because it's around the disc, and it's hyperreflective on OCT?
Yes, exactly. So it's good to know that their nature is actually that they are herniated optic nerve fibers that bulge just external to the optic disc itself. So they are in the peripapillary region just above Brooks membrane. And you can look, if you see the photo, you can actually see exactly where they're located. They're ovoid. That means that they're egg-shaped on a cross-sectional image of OCT. And mass-like, it's because they actually occupy space, right? So they push the layers above them, and it gives them this ski slope appearance that is often described with Phoms.
Now, early on, I thought Phoms was for disc drusen. It's not the case?
So that's what we thought, you know, in the early ages of OCT, before we actually had access to enhanced depth imaging OCT, so the EDI OCT that we now use very commonly, it was hard to describe the deeper structures of the optic nerve down to the lamina cribrosa, right? So we didn't have enough quality of imaging and especially depth of imaging to know exactly what Phoms were. And in the early ages, I would say probably in the early 2005, we started describing them better later on, but then they were often confused to be non-calcified drusen. But the more we studied images, especially with EDI OCT, the more we found out that they were completely separate, different structures. And now we know better that they are actually nerve fibers as opposed to disc drusen, which are a calcified lesion, as we know.
So maybe you could just walk through what the figure is showing here in our little visual abstract, A, B, C, and D, and then we'll describe it for the podcast people.
Yeah, for sure. So, and in figure A, you can actually see some of the features that we just mentioned, right? So I don't know if we can see exactly. So that is where the Phoms is, where you're pointing. So you can see that above that, you have this ski slope appearance. So that's when the structures are sloping like this because the lesion is actually pushing the structures up. If you look at figure B, you can just see the appearance of the optic nerve, and you can see that the margins are sort of blurred, right? You can wonder, is that, you know, a disc that's swollen? What's going on with that disc? So you can see in a C shape that you have this not well-defined margin of the optic disc. In figure C, you have, and the pink dots are actually some of the key structures of the optic nerve head. So you see the opening of the Brooks membrane down there, and then you see the limitations of this Phoms that's pointed with also the yellow arrow. And figure D is just another example of the C-shape appearance of the Phoms. So that's exactly the full extent of the Phoms. So it's a C-shape, and if you look in 3D, it actually looks like an incomplete donut, right? So it's 3D, it's ovoid when you do a cross section, but it actually is a full, like, it's an incomplete donut.
So for our podcast subscribers, you're just going to have to imagine that it is really a peripapillary and hyperreflective ovoid mass-like structure. So if you have that in your head, you can kind of see what we're already seeing here on the video cast. Mm-hmm. And it can be associated with disc drusen, but also just anomalous discs and with papilledema. And so how do you use the Phoms, Elizabeth, if at all?
So it's really hard to know, right? In the beginning, I had the impression that we could, in people who had quote unquote normal optic nerve in which we saw Phoms, and I thought that we could, exclude papilledema, if you will, in those people, but that's not true. We know that that's not true. So it's just a good thing to know what they look like and to differentiate them from optic disc drusen. But to me, it's just interesting to know that they're there, but we can't overinterpret their meaning because the only thing we know is that they're associated with exoplasmic stasis, and that's about, what we know. Do you use them in a different way?
No, in fact, usually when my residents and fellows ask me about the Phoms, I say, don't look at that Phoms. We're going to use every other characteristic of this OCT to try and differentiate disc edema from pseudopapilledema, and anomalous discs have it, and normal people who have nothing wrong with them have it. So I personally don't use the Phoms for making a diagnosis. What I use the Phoms is as a landmark to show my resident that this is a marker of axoplasmic flow stasis. And now let's try and figure out what the actual cause of that is. But the Phoms itself, I do not think it's a diagnosis. I think it's just a wonderful acronym that describes something that we see on OCT that we didn't know what it was before. And so this paper adds a lot of information about doing the Phoms on OCT, but also raising all sorts of questions about what do we do with findings that are new on OCT. And I think that's the fabulous and fascinating part about science.
Yeah, for sure.
Well, I want to thank you, Elizabeth, for participating in our very first inaugural podcast and videocast. And hopefully we'll see the rest of y'all next week.
Yes,
Same time, same channel. Thanks again.